Alright guys, welcome to this page of the notes, and what we've got here is we've got another rational function that we're going to go ahead and graph. But before we do that one, I goofed. I made a mistake on the previous page of the notes. Let me jump back there real quick. You may have noticed and thought, gee, what the heck is going on? I forgot about my point discontinuity. The hole in the graph. Remember, down at the bottom, we figured out that actually, because I had the same value show up as an x-intercept and a vertical asymptote, and that was x equals -4, right? That's actually going to be point discontinuity. So at x equals -4, I just need to put a little hole in my graph. I'll put it right there. There's that hole in the graph, right? And so what that means is that my function, this rational function, does not exist at x equals -4. You plug in a -4, you get a 0 on the top. Plug in a -4, you get a 0 on the bottom. That is the indeterminate form. The function does not exist, and on a graph, that'll show up as a hole. Sorry, I forgot about that. I apologize. But that's why I have you show your work, right? If this were a test question and you forgot to put that hole in there, I can see you know how to do it because your answer's down here. You just forgot to put it on the graph. That's all right. You're not going to take, you certainly won't miss the entire question, maybe a point or two, but not that big a deal because I know that you know how to do the algebra. Awesome. Here we go. This rational function. Let's just jump into it and see how it goes. Maybe it'll be an easy one, maybe it'll be a tricky one, maybe it'll be somewhere in between. I don't know. Let's find out. Here we go. We have got all of this really good stuff where I kind of give you this nice little roadmap, so let's just jump right into it and see how this one goes. I need to set my numerator equal to 0 to find the x-intercepts. My numerator is an x squared. What is my numerator? X squared plus 3x minus 6. Right, minus 6, yeah, minus 6. All right, if we're lucky, it's going to factor into two binomials. I'll spot you the easy bit. Now the tricky bit, I need two numbers that multiply to a -6 and sum to a +3. And you think, and you think, and you think some more. Bummer. All right, so there are no integers that multiply to a -6 and sum to a +3. All right, that's all right. We can do this. Not possible. Not possible using integers. Remember, that tells me one of two things. Either my x-intercepts are decimals, or my x-intercepts are imaginary numbers, and I don't have any. But the only way you'll know which it is to go ahead and find another way to factor this guy. You can either complete the square or use the quadratic formula, and I prefer the quadratic formula. So that's what we're going to do. We're going to do a quadratic formula. Let's do that guy right over here. All right, so quadratic formula is x equals -b over 2a plus or minus b squared minus 4ac square root all over 2a, plug and chug. All right, in this case, my b is a 3, so I'm going to wind up with -3 over 2 plus or minus, it's going to be a -3 squared minus 4 times 1 times a times a -6 all over 2. All right, x is equal to -3/2 plus or minus. All right, I do all of that stuff inside, underneath of the radical. -3 squared is a 9. That's going to be a positive 24. 24 and 9 should be 33. So I wind up with the square root of 33. Oh. Now I know what kind of answer I'm going to get. Since I'm not taking the square root of a negative number, they're not going to be imaginary. I just have x-intercepts. I do have x-intercepts. They just happen to be decimals. That's fine. Let's go ahead and figure it out. Use your calculator. Take the square root of 33. Divide it by 2, and we wind up with x is equal to -3/2 plus or minus. And then as a decimal, actually, sorry, here, let me, real quick, I got a calculator right here. Square root 33, we divide that by 2. I get, obviously you'll have to round, 2.87. Anyway, neither here nor there. Two x-intercepts, right? -3/2 plus this number, -3/2 minus this number. Let's just approximate them. I get x is approximately 1.37, and x is approximately, again, we have to round because the square root of 33 is an irrational number, negative 4.37. So anyway, my x-intercepts, I do have x-intercepts. I will cross the x-axis of those guys. So again, we'll do the best job we can plotting those x-intercepts. But I do have x-intercepts. They're not imaginary. I do have them. They just happen to be decimals. All right, great. So I go back up here. And x-intercepts. I just wrote them down at the bottom. You can just copy them in here. X is approximately 1.37. And x is approximately negative 4.37. All right, no problem. Great. Vertical asymptotes. Set the denominator equal to 0. My denominator is an x minus 2 is equal to 0. X is equal to 2. So I have a vertical asymptote at x equals 2. Okay, great. Horizontal asymptotes. The degree of the top, degree of the bottom. Well, ax. Bx. The degree of the top, 2. Degree of the bottom is a 1. Ooh, okay, well that means that ax is greater than the degree of the bottom. That's rule number 1. Okay, that tells me that I have no horizontal asymptote. I, in fact, have a slanted asymptote. And so now we got some more work to do. All right, no problem. Here we go. There's my rational function. I need to find my slanted asymptote by doing either long or synthetic division. Remember, synthetic division works if the leading coefficient is a 1. Yes. So let's practice synthetic division. Remember the way synthetic division works? You start by setting the denominator equal to 0. And this is the number you'll do synthetic division with. Now remember the way that you set it up? You still need placeholders if you're missing any degrees of x. X squared, x to the first, x to the 0. I'm not missing any, so I don't need any placeholders. This value that I'm going to do the synthetic division with goes inside of the bracket, and then I just pull out the coefficients. 1 plus 3 minus 6. 1, 3, negative 6. I then use a bar to separate my work from my answer. The way synthetic division works is you bring down the first value, so the 1 comes down, and then you multiply and add until you run out of numbers. But just like with long division, I'm finding a slanted asymptote. The remainder doesn't matter. We don't care. So 2 times 1 is 2. 3 plus 2 is 5. 2 times 5 is 10. Negative 6 plus 10 is 4. That last guy is my remainder. He doesn't matter. All I need is my quotient. How do I put my variables back in? What is the degree of the original polynomial? Well, the degree was a degree 2, second degree. Your reduced polynomial, or your quotient, will be 1 degree less. Since it was a second degree, this needs to be a first degree. So, x to the first plus 5. X to the first, x to the 0. And so this guy right here is my slanted asymptote. I have an oblique asymptote at y equals x plus 5. This is in slope-intercept form. Y equals mx plus b. Y equals mx plus b. All right? Now, I have no horizontal asymptote. That's because I have a slanted asymptote. Do I have any points of discontinuity? I don't have any values that are both x-intercepts and vertical asymptotes. So the answer is none. And here we go. Let's put all the pieces of this puzzle together on our graph and see what happens. Okay, here we go. So first, let's do our vertical asymptotes and our slanted asymptote. I had a vertical asymptote at positive 2. All right, there's my vertical asymptote. My slanted asymptote has a y-intercept of 5, a slope of 1. 1, 2, 3, 4, 5, so right there, and then it's just going to have a slope of 1. So it's going to go like that. Could go down 1 and back 1 if you wanted to. Anyway, my slanted asymptote's going to run right through there. All right, now, my x-intercepts. I actually have 2 x-intercepts. Yes, they're decimals, but they're still x-intercepts. So let's go ahead and put those guys in here as well. Remember, I had an x-intercept at about 1.37. So 1.37 we'll say is somewhere right about there. Again, we're freehanding it, so, close enough. The other one was at negative 4.37. 1, 2, 3, 4.37. Again, we're freehanding it. It's right about there. All right, now I put all the pieces in there. Now we have to make our graph fit the pieces. I cannot touch the asymptotes, and I've got to go through those x-intercepts. Again, there's only one way to make this work. That line approaches but never touches my asymptotes and goes through my x-intercepts. Since it goes to negative infinity on this side, on the other side, it'll have to come from positive infinity. Doesn't really quite fit on this graph, but it's pretty close. It'll go right in there somewhere. That's good enough. Again, it's a sketch. Do you know how to do the algebra? Can you show me how to find all of the pieces that you need in order to get a picture of the graph? All right. Again, that one is a little bit more similar to like the first one we did, but again, certainly something that if you're taking this class with me, I would expect you to be able to do on a quiz or a test. Yeah, they're long. Yeah, they're complicated. There's a lot of stuff going on, but the more of them you do, the more practice you get, the better at it you'll become, and the faster you'll get at it. Head on over to the next page of the notes. We'll try another one of these. I'll meet you guys there.